Welcome to Millionlights. My name is Pratik Shah. I'm an assistant professor in DY Patil School of Engineering. In the previous module, we had discussed about ultrasonic sensors and PWM. In this module, we'll be discussing about DC motors, how to interface them with Arduino, and how can we get the desired results with them. So let's start with DC motors. DC motor is a type of motor in which we have got two terminals. Now actually there are a lot of different types of motors such as DC motor, stepper motor, servo motor. Each has its special characteristics and special uses. Today we'll focus on DC motors. DC motor are of various types, as I said. This is one DC motor, then we have different DC motor. Now all the DC motors will have two terminals. As you can see here, we have got two terminals. Now in the same way, this motor has got also two terminals. Now you can connect them using these wires so that they can be easily connected to Arduino or breadboard or whatever you want. Okay, so we have different types of DC motors, and these DC motors are very useful in doing lot of stuff. Like we can use them for controlling the speed of a robot. We can connect wheels to the shaft of DC motor. Now this is the shaft. Here some DC motors have shaft on the side, whether some have on the top of them. So we connect the wheels of the robots to these, so we can control them, we can move them in any direction we want by controlling the DC motors. DC motors. Now this is how a DC motor looks like. DC motors have various different types. This is one type, then this is another type. All are the same, the functionality is same. They have got two terminals. Okay, so all DC motors, if you take, they will have two terminals and they have a shaft. The shaft can be either at the sides or it can be at the center. So we have got shafts and we have got two terminals. So with the help of a shaft and two terminal, we can do lot of things. These two terminals are provided or used to give supply voltages to them, and based on the supplied voltage it will rotate the task. Now the thing is, this is a DC motor. Similarly, we also have stepper motor, servo motor. Now stepper motor has got 4 pins or more than that. Servo motor has got 3 or more than that. Those are for specific task, and this is for a specific task where we have to just move it in clockwise or anti-clockwise direction. Now how does a DC motor work? As you can see, we have got two terminals provided over here. Now when you apply a specific or a prescribed voltage to it, then it will start rotating, and it will rotate in clockwise direction and anti-clockwise direction depending upon the polarity. Suppose I apply 9 volts at this terminal and ground to this terminal. This motor will rotate in clockwise direction. Now if I do the opposite, apply 9 volts in here and ground in here, it will rotate in anti-clockwise direction. So the thing is, motors are having specific voltage range, such as this one is having 9 volts, then this one is having 5 volts rating, few of the motors have 12 volts ratings, and so on. So they are prescribing the voltage ratings at which you have to use. Okay, so now we know that if we apply a prescribed voltage, then the motor starts rotating, and that specification is given with the data sheet, or when you purchase the motor, the vendor will tell you that, or it is written on the box of it. Now that tells you just about the operating voltage. Now what about the speed of it? Few motors are having 60 rpm, few are having 100, few are having 200 rpm. Now this one that I have here is of 60 rpm. The rpm means rotations per minute. That means the shaft will rotate 60 times per minute. So there are few which are having 100 rpm, 200 rpm. So depending upon your application, your speed, you can select them. Now the same thing is applied to all the DC motors. They come with different operating voltages and different RPM. Along with that, they also specify the torque. Torque is the capability or the load that it can take. So now we'll just focus on the operating voltage and the RPM. So we have got these two DC motors and we'll be using them. So to Can we use them in the same way as we used for switching on LEDs? Can we use Arduino, and from Arduino pin number 13 we can switch on the motor and connect the second terminal to ground? Will this motor rotate in clockwise direction? The answer will be no. Why? Because these motors require a lot of current. So they require a lot of current for operations, and our Arduino cannot provide that much amount of current. The current capability of Arduino is very less, 20 or 40 milliampere, and the current required for this is a lot. So we cannot directly connect this to Arduino and think that it will work or it will rotate, or we cannot control the motion of it. Then what can we do? So for this purpose we require some external thing, some external power supply or kind of thing. So now what I'll do is we'll take a power supply, we'll connect it to, and then we'll see how it rotates. Let's take a power supply. We are taking a 9-volt power supply here along with us. Now we'll connect this power supply to the motor and let's see how it rotates. Okay, so I'll keep this one aside. Now this is the positive terminal and this is the negative terminal. So I am connecting positive terminal of it in here and negative terminal in here, and now you can see that motor is rotating in clockwise direction. So it's very simple. We have got two terminals, connect them with the prescribed voltage and the polarity. If you correct positive and negative, then you will get a clockwise motion. Now if you just reverse the polarity, if I connect the first terminal to negative and the second one to the positive, then what do we have? We have the motion that is in the anti-clockwise direction. So the operation of motor is quite simple. You just provide it voltage in the positive and negative direction, it starts rotating, and if you change the polarity, it starts rotating in the reverse direction. So all the motors operate on the same principle and the same thing. But now every time, suppose I am creating a robot, I want it to move forward and then come back or whatever, I want to control the motion. Now I cannot do this thing. You can see that there are tedious things. I have to take the motor, then change the polarity. I cannot do it by my hands manually every time. I want the robot to be autonomous, or it should be controlled by the controller, or it should take its own decisions. So I cannot make these manual connections. Therefore I need Arduino to control it. But the problem is Arduino does not provide the current and the these power that is required for driving this motor. So what do I do? What can I do? For that I require a device which will do, it will take commands from Arduino, and according to that commands it will take the power supply, external power supply, and it will provide that supply to the motor. So what I am doing is I am controlling the motor with Arduino, but the supply is provided by some external device. For that I have this IC. This IC is called as L293D, L293D motor driver IC. This is a 16 pin IC. We'll see the details of it and the pin diagrams and descriptions all later on, but I'll give you just a brief introduction. We are having an IC whose name is L293D. It is having 16 pins, and this is useful for connecting Arduino with the motor. It will act as an interface. Arduino will give commands like move it clockwise direction, stop it, move it in anti-clockwise direction. Those commands, those instructions will be given by Arduino to this L293D IC, and this IC will take the help of this external power supply. So this will take 9 volts and the current from this, and it will supply it to motor. So we have an interface, that is an IC, Arduino and the motor, and the power is supplied by this thing. So we'll see the pinouts and all these things, but before that let me tell you what is an IC. IC is an integrated circuit or integrated chip, we call it. It is composed of millions and millions of transistors. Small tiny transistors are used, they are compacted and they are integrated onto this chip. So we see just one chip with 16 pins, but it has got more than million of transistors. Now we'll start with exploring the concept of L293D and how we can use it. Let's start with L293D. Now we'll explore what is this IC and how we can use it and all the things. So I have told you that it is a 16 pin IC and it is used for controlling the motor from instructions obtained by Arduino, and it will take the power supply that is available from the battery. So what we are going to do is, first Arduino is going to be here. Arduino is going to give commands to this IC, and this IC is going to pass on those commands to this motor. Now IC is going to pass on the commands to this motor because we want to control the motor, and the current provided by Arduino is not sufficient for this motor. So we require this external power supply. So now what is happening is, Arduino is giving commands to it, and based on those commands, this IC is taking power supply from the source and it is transferring to the motor. So without any mechanical or manual change of power supply and connections, we can control the motor by just instructions and sensors and whatever you want to do. So this is how we can say the block diagram, or this is how the working will be. Now this IC is having 16 pins. Now we have just discussed about the working, but we have not discussed about each and every pin and all the stuff related to it. Now this IC is having 16 pins. Now the speciality of this IC is that we can connect two motors to it, and simultaneously those two motors can be controlled using this IC. So if you take a look at this presentation that I have prepared, you will see the pinouts of the IC. We are having 16 pins, and each and every pin is labeled with a name. So on the left hand side part, that is from 1 to 8, we can connect one motor, and from the on the right hand side part, that is from 9 to 16, we'll connect another motor. So here if you take a look at the pinouts, first pin, that is pin 1, is enable, and pin number 9 is also enable. First one is enable 1 and ninth one is enable 2. So enable 1 means what? You want to use the left hand side panel, that is you want to connect the motor on the left hand side. Then enable 2 means you want to connect the motor on the right hand side. So suppose you want to connect only one motor, then that is to be connected at enable 1, and that is on the left hand side. So you have to ground the ninth pin, that is enable 2. So if you are using both the motors and you are connecting on the both the sides, then you are going to use enable 1 and enable 9. So these are the two pins. Now let's come to the next one. On the left hand side, second pin is input 1 and the seventh pin is input 2. So second and seventh are input 1 and input 2. These are the places where you are going to connect the output of Arduino to the IC. So there will be two pins that are coming from the Arduino. So you can take any pin, you can take pin number 4 and pin number 3. So pin number 3 and 4 are to be taken from Arduino digital pins, and they are to be connected to pin number 2 and pin number 7 of this IC. Then what is it? It is the input that is given by Arduino to the IC. Now depending on that, Arduino will do what? It will provide the output and it will give an higher current to this motor. Now for providing higher current, it will require a supply. Now this power supply is to be connected to it. Now which is the place where we have to connect the power supply? The power supply is to be connected at pin number 8. At pin number 8, we have to connect the power supply. That is, the positive terminal of this battery is to be connected to pin number 8. So we are providing external power supply to the IC, and that 9 volts is supplied to the motor. So we have discussed enable, we have discussed input 1, input 2, and we have discussed Vs. Now we are left with just 4 pins on the left hand side. What are those pins? Output 1 and output 2. Output 1 and output 2 is pin number 3 and pin number 6. So pin number 3 and pin number 6 from L29 3D are to be connected to this motor. So pin number 3 and pin number 6 from this IC are going to the motor, and the motor is controlled by this. So instructions are given by Arduino to pin number 2 and pin number 7 of this IC, and this will reproduce the voltage that is given by power supply in pin number 3 and 6. Now we will see that pin number 4 and pin number 5 are ground pins. So we have to just connect them and short them to the circuit ground. So we complete with the left hand side part. Now we are not going to connect the right hand side part because it is the same as the left one. We are connecting only one motor. When you are connecting two motors, you have to use the right hand side part also. Now just one more additional thing that I would like to tell you is pin number 16 is VSS. So VSS is the supply voltage that is to be given to IC for operation, and that is 5 volts. So in this IC you have to provide two supplies. One is VSS, that is 5 volts for operation of the transistors that are available on the IC, and we are also giving a 9 volt power supply, that is this battery, to the pin number 8 because it is to be provided to the motor. So two power supplies are there, pin number 8 for this, and pin number 16 for 5 volts. So this will complete regarding the pinouts of it. Now how is the operation? That is what I will be telling you. Now if you take a look at this presentation, now if input 1 and input 2 are given 5 volts and ground, that is high and low respectively, then the motor will turn in clockwise direction. If you provide an input first as low and input second as high, then the motor will rotate in anti-clockwise direction. Now if you provide 5 volts and 5 volts, that is both high signals to this inputs of this IC, then your motor will be stopped. And if you provide low signal to the IC, then also motor will stop. So for motor to be operational, one should be 5 volts and second should be ground. So if you provide both as 5 volts, motor will not work, it will be stopped. If you provide both low signals, then also motor is stopped. So one should be positive, one should be negative, clockwise movement. This one positive, this one negative, anti-clockwise movement. So this is quite simple. We have got two inputs and the same result will be produced by IC as two outputs which are connected to motors, but with enhanced current and power which is provided by this power source. In the next part, we'll see the circuit diagram and then we'll start building the circuit. Okay, now let's see how the connections will be. I have prepared a schematic in this presentation and we can see the connections. Okay, so the pin number 1, that is enable, it is connected to 5 volts as we have discussed earlier, because we are using the left hand side part and we are going to connect the motor on that part only. So first pin is connected to 5 volts on the Arduino board. Second pin is an input pin, so it is connected to pin number 3 on Arduino board. So second pin is connected to pin number 3 on Arduino. Then we are connecting pin number 3 of the motor to the one terminal or positive terminal of the motor. There is no such thing as positive and negative, but still we can connect pin number 3 of the IC to the motor. Then fourth pin and fifth pin are ground, therefore we short them together and the shorted version is connected to the common ground that is available on the Arduino board. Then sixth pin is the output 2, and then output 2 is connected to the motor. So the second terminal of motor is connected to output 2. You can see with this line it goes up. Then we have seventh pin, that is input 2, that is connected to the D4. D4 is the fourth pin of our Arduino, that is digital fourth pin. So pin number 3 and pin number 4 are connected to pin number 2 and 7 on the L293D IC. Then last one is the 8th pin. As discussed earlier, 8th pin is nothing but VS, that is external power supply. So it is connected to 9 volts battery, that is positive terminal, and the ground or the negative terminal of the battery is connected to the common ground of the circuit. Now just one connection is left and that connection is of 16th number pin, that is V plus or VSS, that is connected to 5 volts on the Arduino board. So the connection is not that simple if compared to previous experiments, because those were very simple, but it's not that difficult, we can easily fix this thing up. So this is how the connection is, and this is how the schematic will look like on the breadboard. Okay, so let's start assembling the things and we'll build a circuit and see the output. Let's start building the circuit. For this we'll require USB cable, Arduino board, battery, L293D IC, jumper wires. A lot of jumper wires are required here. Then we have got breadboard. Breadboard is used for making connections. We'll be mounting our IC onto this only. Then we have got DC motor, and after that finally we have got this small thing. This is a cap that is used to connect battery with the circuit. Okay, so these are the things that are required. Now let's start assembling the circuit. First of all, what we'll do is we'll use this L293D and we'll place it onto the breadboard. So we are placing on the first quarter. Now here we have to take care that it's perfectly going inside, because if the pins are quite delicate and sometimes there is a chance that you can break the leads of them. So we have to take care, and yes, done. So we have completed the task and we have fitted it properly. Okay, now first thing that I'll do is I'll be using these jumper wires to make a rail of VCC and ground. So from Arduino, I'll be taking and using a VCC rail and a ground rail. So I am first of all making what? A rail, that is a vertical ground and vertical VCC thing which is required for all the connections. Okay, now let's start. The first pin is an enable pin and that is connected to 5 volts. So I'll take this and I'll connect it to the 5 volt. So this completes the first connection. Second connection is input and that is to be connected to pin number 3. So second pin is connected to the pin number 3, 0, 1, 2, 3. Yes. Now the third pin is connected to output of the motor. So third pin is connected to output of the motor. So this is a motor and one terminal I am selecting and that is being placed onto the third pin. Okay, so that is complete. Then fourth and fifth pin are shorted together and they are grounded. So directly what I'll do is fourth pin and fifth pin, I'll connect them to the circuit ground. So these two are going to the circuit ground. Fine. Then sixth pin is output 2 of the motor. So sixth pin is connected to output 2 of the motor and it is connected directly. So this is the sixth pin which is fixed properly, I feel. Yes. Okay. So sixth pin is done. Now seventh pin is input, that is to be connected to fourth pin of Arduino. Yes. So it is also done. Now eighth pin is VCC of the motor. So VCC of the battery. So this is the battery and we have to use this cap. So I am using this cap. Yes, so it gets fitted easily and now this is the positive terminal and this positive terminal is connected to pin number 9. Okay, and this is the second terminal, that is negative terminal, that is to be connected to the ground. We'll connect it later on. We'll skip this part for now. Then I guess only one connection is left and that connection is of pin number 16 to 5 volts and that 5 volts is this VCC. So we are done with it. Now we can connect this part. We will connect it to the ground. Yes. Now the only thing that is left is to connect our Arduino board with PC. We'll connect Arduino board with PC and then we can see the results. Okay. So before connecting it, what we have to do is we have to upload the code and all. So we'll skip this part for now. After uploading the code, writing the code, and then only we'll connect it. So this finishes our circuit connections. It's quite messy because a lot of wires are there, but if you see the schematic according to it, if you perform it, it's not that difficult. Now let's talk about the coding part. Before that, let's see what is an expected output. The output that I expect is the motor to be rotating in clockwise direction. For motor to rotate in clockwise direction, it should be provided with plus 5 volts and ground, which is provided by L293D. But for L293D to provide it with that voltages, it is to be controlled by Arduino. So from Arduino, we are connecting two pins, that is pin number 3 and 4. So pin number 3 will be set to high and pin number 4 will be set to low. So these two instructions will be given to L293D and it will emulate it and it will give the same results with more power to this motor. So the code is quite simple. If you take a look at this code, it is having just 6 instructions. Two functions are there. One is void setup, void loop. In void setup, two initializations. First one is pin mode 3 output, then second one pin mode 4 output. As pin number 3 and 4 are used in output mode, and then in void loop, what do we have? We have written digital write 3 high, digital write 4 low. That means what? We are sending 5 volts from pin number 3 and from pin number 4 we are sending a ground or a 0 volts. So this is sent to L293D and it passes on the same thing to the motor. and the motor will rotate in clockwise direction. Let's type the code into Arduino IDE and upload the code and see whether it's working properly. The thing is, I've already pasted the code. Now we'll first compile the code whether it's correct. Okay, the code seems to be working. In the meantime, what I'll do is I'll connect the USB also. Okay, so it's compiling. By the time I'll connect the USB. Okay, so the USB is connected. Okay, the code is compiled and it is having no errors and it's perfectly alright. So I'll upload the code and we'll see what is the output that we get. Code is being uploaded. Okay, and here we see the output. The motor is rotating in the clockwise direction as mentioned, and you can see that it is not stopping, it is continuously rotating because the instruction given to it was just 3 is high, 4 is low. That means you have to give it 5 volts and ground and it will rotate continuously. So this is the code and it is working properly. Now the speed of it is maximum, which is 60 rpm. If you want to increase the speed of it, you have to bring another motor which has more rpm. One thing you can do is you can reduce the speed of it using PWM. We'll see that in the next module. In the previous experiment, the output was what? The motor was rotating in clockwise direction, that's it. Now, we want to control the motor, means what? We want to rotate it clockwise direction, we want to stop it, we want to rotate in the reverse direction, and we also want to control the timing. Say I want to make the motor to move for 5 seconds in clockwise direction. Then I want it to stop for 1 second. Then I want it to rotate in anti-clockwise direction for more 5 seconds. And then this process is to be continuously repeated or something like that. So how can we do that? In the previous thing what we saw, just switching it on and it was continuously rotating. We want to control its direction and its movement, and we want to also stop it. So for that purpose we have to write a bit of additional code. So that is what I have prepared in this presentation. Now here you will find the void setup part is same, but the loop part is changed. The loop part is changed depending upon the output that we desire. The desired output for me is the motor to be rotating in the forward direction, that is clockwise direction, for 5 seconds. Then I want to take a break of 1 second, that is I want to make it stop for 1 second. Therefore I have written a code, I'll explain it. Then I want it to rotate in anti-clockwise direction. Then once again I want it to be stopping for 1 second. So according to that I have written the 4 chunks here. The first chunk is what? Digital write 3 high, then digital write 4 low. That means what? Pin number 3 and 4 are used for making the motor to move in forward direction. In the previous case same thing was done, but an additional delay is given here and the delay is of 5 seconds. So the motor will be in forward direction for just 5 seconds. After that I want to stop it. For stopping it I can either make 3 and 4 high or 3 or 4 low. So I made pin number 3 and 4 as low and I have kept it for 1 second. So it will rotate for clockwise directions in 5 seconds, it will stop for 1 second, and then it will take an anti-clockwise rotation for next 5 seconds, because in the next chunk what I have written, detail write 3 low and detail write 4 high. So it is the opposite polarity which was written in the previous thing. Then once again 3 and 4 are low. So the thing is, output is 5 seconds clockwise direction, stop, and 5 seconds anti-clockwise direction, stop, and the same process is repeated. Now what we'll do is we'll upload the code onto the Arduino board and we'll check how it performs and does it perform according to that. Now we'll type the code into Arduino IDE and we'll see what the output will be. Okay, so for reducing the time I have already pasted the code onto Arduino IDE. We'll first compile the code, check whether it's correct, and after that we'll upload the code. Now it's compiling and just we'll wait for 1 second, it will be completed with that. Okay, so it's having no errors. Fine. Now we'll upload the code onto the Arduino IDE and we'll see how it does. Yes, so the code is uploaded. Now we can see it is rotating in the clockwise directions. It will rotate for 5 seconds and after that it will stop. Then in anti-clockwise direction, stop. Same thing, clockwise direction for 5 seconds, it will stop. Then it will rotate in anti-clockwise direction for 5 seconds and after that it will once again stop. So you can connect a wheel or anything to it and you can program it accordingly and you can get the things done. Okay, so in this module we had discussed about DC motor, how to control it with Arduino and how we are using L29 3D for that purpose. Now with this basics, you can start with making a simple robot and you can connect a wheel to the motor and start rotating it and doing all kind of stuff. In next modules we'll be using and we'll be making a robot that is autonomous and it is controlled by Bluetooth, by mobile, and a lot of different things are going to be done. Now this simple basics of DC motor can be used in a lot of various applications. You can use it for access of your room. You can make a lever out of it and you can rotate the motor to open or close the door. So depending upon that, if a person is valid, he can enter or something like that we can do. Hope you like the video. If you have any queries, you can find us on Facebook by the name Millionlights or even on Twitter. You can visit our website www.millionlights.org for more such interesting courses. Thank you.